So, scientific notation, we're going to kind of review what is it, how do you write it in scientific notation, how do you do some calculations in scientific notation if your calculator just died and you're in the middle of taking the ACT or something like that, so that it really matters, or the SAT. And then we're also going to do some other word problems where they give us two sentences and we have to figure out the equations that we want to use with that. So you guys did a good job remembering that we're going to use these for really big numbers and really small numbers. When it's a really big number, we're going to have 10 with a positive exponent. And when it's a really small number, we're going to have 10 with a with a negative exponent. We're looking for some coefficient number times 10 to some power. And then the decimal has to be, you have one number that's not 0, and then you have the decimal. So 2 points, or 3.461, but not something like 0.2. You've got to have one number that's not 0, and then the decimal. If you move a decimal to the right, so if you have a number in there and you move the decimal to the right, you're making the coefficient bigger. So to keep things balanced, you have to make the exponent smaller. What I mean by that, if you have some examples here that start off on the left, not in scientific notation because the decimal's in the wrong place. 0.0004, oh, I know that needs to be 4.0. So I just made that part bigger. It was 0.0004, now it's 4, it just got bigger. So I know I have to make the decimal, or the exponent smaller to keep it balanced. So if I move this 1, 2, 3, 4 places, I need to make this exponent 4 smaller so that I have 4 times 10 to the minus 10. If I start off with 0.0023 and I know the decimal is supposed to be 2.3, I just made that number bigger when I moved the decimal over. I moved it 2 places, so I moved it 3 places, so I need to make this one 3 places smaller, so I subtract the 3 and have 2.3 times 10 to the minus 1. If I go the other way, my number's too big and I need to make that first number smaller, then I have to make the exponent bigger to keep it all balanced. This one, I need to move the decimal to the left and make that 5, so it's now smaller than I started with. I moved it 2 places, so I make that exponent 2 bigger. This one was 34,000, that's too big. I'm going to move the decimal and make it 3.4, so I just made that coefficient smaller. I moved that decimal 4 places, so I need to make the exponent 4 places bigger. And negative 2 plus 4 gives me 10 squared. The other thing we're going to review, like I said, is how do we do some calculations with scientific notation if our calculator dies and it's a big test, and it really matters. So if we have some things in scientific notation, we're going to multiply the number parts, and then we're going to put all the 10 to the powers together using our exponent properties. If we're going to divide, we're going to take the number part, the coefficient in the top, divide that by the coefficient in the bottom, and then we're going to have 10 to something over 10 to something, and we're going to use our exponent properties to simplify that. And that'll make a little bit more sense as I do these examples on the next slide, or this example. So, for this one, I'm multiplying in the top, I'm multiplying in the denominator, and then I have to divide the numerator by the denominator. So one way you can do this when your calculator is died is write these in scientific notation. So this should be 5.6 times something. I like to get just what is the 0.00056 in scientific notation, and then worry about the times 10 to the 4th instead of doing it all at once. For this one, I'm making this number bigger, 1, 2, 3, 4 places. I really need a small number, so that needs to be 10 to the minus 4. 5.6 times 10 to the minus 4 would be 0.00056. And then I also had this other times 10 to the 4th for that first parenthesis. This one's nice. It's already 7 times 10 cubed, so I'm not going to do anything to it. What should my decimal be for the first one in the denominator? What should my coefficient look like? Adeline? So I need 4.9 for that, so that the decimal's in the right place. 1, 2, 3, 4. I made it 4 places bigger, so that piece needs to be a 10 to the minus 4. And then I've still got this other times 10 to the 16th in that parentheses. And then this one, my decimal should just be 2. And let's see, 1, 2, 3, 4, 5. 10 to the 5th or 10 to the minus 5? Minus 5. And then I still have this other 10 to the minus 5 in there. So then what I need to put together, all of the coefficients, 5.6 times 7, 4.9, and 2. And then I'll need to put all of my terms together somehow or another. There's a bunch of ways you could go with that. I'll write them all out. Just I wouldn't if I was doing this on a problem set, but 10 to the minus 4, 10 to the 4, 10 cubed, 10 to the minus 4, 10 to the 16th, 10 to the minus 5, 10 to the minus 5. Those are all the ones I'm working with. So for this, I notice, oh, these have the same number of decimal places. So if I think of that as 56 over 49, those are both divisible by 7, right? So that part becomes 8 over 7 and 7 over 2. And that's pretty easy. What does that equal? 4. So that part is just 4 in my numerator. Okay, put the terms together in any order that you want. I would probably say, wait a minute, 10 to the minus 4, I could either do 10 to the minus 4 times 10 to the minus 4 is 10 to the 0, that's a 1. Or I could say, if it's 10 and they're both minus 4s, 1 in the numerator, 1 in the denominator will cancel. So 10 to the 4th over 10 to the minus 4 does not cancel. One's a 4, one's a minus 4. They've got to exactly match. In the numerator, looks like I have 10 to the 7th, right? In the denominator, 10 to the 16th, minus 5, what's that? 10 to the 6th. Did I do that right? Thumbs up, thumbs down, check my work there. I wasn't looking at my paper. With scientific notation, you're never going to leave anything in the denominator. It has to be in the numerator. It can have a negative exponent if you need it. This one doesn't. This one is simply top heavy, 1 extra 1 in the numerator. 4 times 10 to the 1st if I want to be real technical about scientific notation. This one, if you said 40, I'm okay with that. I want to point out your calculator, if it was, I don't know, 2.34, and actually had a bunch of other places, e to the 6th, you may not write it like that. You must write it 2.34, use an x for the times, and a 10 to the 6th. So don't just copy what your calculator says, shift it to the way we write it. Daniel.
What does the E mean?
And it's the times 10 with an exponent of. When you see that. So be sure you're always looking way over on the right side of that calculus later screen. And pay attention, is it an e to the 6 or an e to the minus 6? What do they have in there? All right, let's do the word problems. So when you have one that it's a bunch of words and it talks about you've got numbers and the ratio of the numbers is something, and then they tell you something else. The sum is this, the product is that. I think the best way to do it is to say ratio means fraction. So ratio of two numbers, pick any letters you like. Pick X and Y. Pick C and M. I don't care. They don't tell you the letters, so you pick whatever you want them to be. If we do X and Y, that means the ratio of X to Y, we can write it as a fraction, is 4 to 5. That's one of the equations I'm going to work with to solve this thing. Anytime you have one that's a ratio is, take your cross product and say that means 5x equals 4y. And that's going to be one of the equations in the system we need to solve it. So write it as a ratio, write it as fractions, do the cross product, and then you have that equation. Sum means we do what? We need to add them, so we're going to write down if we add them, we have 108. So let's do substitution. X is 108 minus y. And then we're going to put that in here. So 5 times 108 minus y is 4y. 540 minus y is 4y, or no, minus 5y. Told you guys to be checking me. At least I caught that one myself. Add 5y to both sides. And y is how much? It's going to be 60. And x is 108 minus 60. Everybody, what is that? Does that mean if you solved it and said x is 60, y is 48, you got it wrong? No, it just means you set it up a little bit differently. You set it up with y over x, and I set it up with x over y. That is not wrong. If you got A is 48 and B is 60, is that wrong? It did not tell you what letters you had to use. So technically your answer is simply the numbers are 48 and 60 because the letters have nothing to do with it. Bryce?
So do we have to set it up this way, or can we do a ratio?
I asked me the same thing last period, and the answer is yes, you can use a ratio box on this one, but it's not going to work on some similar ones. Happened to work on this one because it says sum. Let me go through a real quick example of why that would get you in trouble. Let's suppose that my numbers, I'm going to do this backwards, that I want for my answers are 12 and 15. But I don't tell you that. I tell you that their ratio is 4/5. And then what if I tell you their product is 180? And you start trying to set up a ratio box on this. So you say, okay, I want the numbers be x and y. The ratio is 4 and 5. So then instead of a total, you try to do a product. And then you start trying to do something with your ratio box. So maybe you use these two rows first, and you say 5xy is 20y, and then you try to divide both sides by 5y. Well, as long as y isn't 0, I can do that. But then you get that x is 4, but it's really supposed to be 12. So that's why I say it's a yes, but you have to be really, really careful. It worked because it was a plus on that one, but it's not going to work on all of the ways they might describe a problem. But great question, and I love that you guys are trying to think that through. So let's do one more. The sum of the numbers is 136, and the difference is 50. So everybody pick what you want for your letters, and write down 2 equations for that. And then we're going to talk about what we got. Tell me what you wrote down.
I put x equals y equals 136, and then I put x minus y equals 50.
Okay, did anybody do anything different? Anybody use different letters? Did anybody say x plus y is 136 and y minus x is 50? Could I have done that? Yeah. There's nothing that says which letter has to be which number. This one simply means y happens to be the bigger one of the two. I took bigger minus smaller to get a positive. I took smaller minus bigger, I would have gotten a negative 50 there. This one simply says, without writing it down, x is the bigger one and y is the smaller one. So we could have done it either way. So now let's go through and solve it. What method do you want to use on this system? You're kidding me. You want to make it that hard? Oh. Let's do elimination. We've already got a plus and minus y. Let's just say 2x is 186, divide both sides by 2, and x is 93. Did I do that right? Does that look right? So then if I plug in 93 plus y is 136, or 93 minus y is 50, y has to be what, 43? Now, if I did it this other way, work would have been the same, but I would have ended up with y is 93 and x is 43. But are they both right? So technically, I should have said the numbers are 43 and 93 and not worried about which is x and which is y. Because it doesn't say which way it has to be. I just want to stress that, so as we're checking or as you're comparing with a friend, if they say, oh, I got x is this and y is that, and yours was just the reverse, it's like, wait a minute, the book didn't say what letter had to be what. We're both right. So you don't confuse yourself when you check your answers with what a friend got.